Hi, my name's Fxsmith. I'm going to narrate this video for you. Before Benjamin Button got financed, I was asked to help test two of its technical issues. The first request was a 75-year-old bust of 35-year-old Joel Bissonnette for Digital Domain to explore the feasibilities of digital head replacement. So we made them a permanent, intrinsically colored platinum silicone bust from which they could reference and scan form, pore structure, color, opacity, and/or hair growth patterns whenever they needed the information. There was a very specific request for a brush cut, so the computer was going to need Joel's hair growth patterns just like any wig maker would. His facial hair had its own patterns. All of that was there to reference. They say in the end they didn't use any of the information from Evan's bust, but it did become valuable years later to test lighting for the final multi-camera approach. It also set a standard going forward.
It was the first test for Benjamin Button. And in here you can see that's a computer-generated head. It's pretty good, attached to the body of another actor, and it worked. And it gave the studio great relief.
The test helped them raise close to $200 million to make the film. The thing I noticed was that he didn't have a brush cut, because our second request from them, and the subject of this video, is the hand punching of that brush cut into a 65-year-old platinum silicone gel prosthetic for Joel. We've been punching hair into our prosthetics for years, but a brush cut would truly test the limits of that approach. The prosthetic to punch the brush cut into is the real test for us, the chance to explore how practical and repeatable we could make that process. For example, Evan Penny's bust, you have just seen, tested a whole new intrinsic color approach that, if it worked for the prosthetic, opened a whole new world of possibilities. It all started with this Plyo-Life head cast of Joel Bissonnette, a permanent first-generation negative from which we could pull second-generation positive detail. This is an untouched positive out of that mold. You can see how crisp the skin detail is. There's a reason for that. In turning a silicone into a body casting material, a filler is added which separates one molecule from the next, taking the grip between them away. It is that physical property that allows a silicone to be released safely from skin. What the filler also does is give us a much crisper detail than any other mold material we ever used. While Joel was still in the studio, we mapped out the growth patterns of his hair just like a wig maker would. We photographed him, and we made this makeup sample of his skin tones. At the end of the day, that's the only reference to color we ended up having. Then we made a plaster bust to map out the prosthetic appliances. We took too many risks here trying to accommodate the hair punching, but we had faith we could make all our seams disappear. We had tested a topical silicone paste called Third Degree to bond and repair edges that did everything we needed it to do. It was a luxury that unlocked a lot of doors for us. Evan Penny sculpted and lifted each appliance onto their own ultracal core, which we then put to mold in urethane. Urethane, so there is no release required for our silicone appliances. White, so we could see proper color in layup. We marked the molds where each prosthetic needed a blend edge to the skin and how wide that edge had to be in blue. The rest of the prosthetic was designed to butt up against the next prosthetic with no blending edge, just form. Each edge would have its own barrier coat that would help hold its form and application. We had taken the same approach on our very first prosthetic for Gordon Tatuzzi in Legends of the Fall. It all starts with the barrier coat. We use broad, flat brushes to drag out thin layers of silicone, starting by releasing those brushes with Vaseline. That and a good metal brush kept them alive. 99% alcohol and dilaminine cleans up the rest. Palette knives, clean wooden stir sticks, tongue depressors. And most importantly, make yourself a few little plastic cup holders, ones you can put in the vacuum to keep your cup from flying around. Our platinum silicone barrier was a shorthand because we found it had the properties we needed to simulate the qualities of that firmer outer layer of skin. 244 silicone fluid let us thin it for a thinner and easier application. Jay is applying that barrier coat here. The urethane mold has been released with a fine mist of parafilm wax. It is important that the surface of the mold remain matte, like skin, which is why we used a mold material we did not need a release for. Pore structure was important to us because it was the surface camera and light needed to see the same way it did an actor's skin, like the translucency of skin. If matched in the prosthetic, both light and camera will see them the same. Two very important parts of the illusion, both the responsibility of the sculpt. Color and movement was the responsibility of the prosthetic. Movement came from three elements: the relationship between the barrier and the interior gel that simulated the physical relationship between the surface layer of skin and the softer tissue below it, the softness of that interior gel simulating the softness of that subdermal tissue, but more importantly, the simulation of the very specific movement qualities unique to skin or meat, qualities not present in any synthetic polymer. Qualities that did give any platinum silicone by percentage, as it controls softness. Every element was being tested with the goal of simplifying process and its repeatability. Our color approach was the most serious sidestep, but its potential was crazy. Evan Penny proposed the theory and tested it in the fabrication of his 75-year-old bust of Joel Bissonnette. I found the bust a little too opaque, but we could always apply less flocking. It would always be backed up by an interior skin tone. We had a lot of choice. A day or two in the studio with Joel to color match the prosthetics to him, and we could start building appliances for the test. We colored our prosthetics as we made them. Always did. Nothing new. Crazy as it seems, we weren't given access to Joel to do that, so it never happened. Our only color choice left was to match the prosthetic to Evan's 75-year-old bust. We altered his process with one more coat after the barrier coat was cured. A thin layer of clear, deadened interior gel on which to apply our color, flocking, an application that happened before the gel cured. A cool gel cures in approximately 10 minutes, meaning both the application of the gel in the mold and the application of the flocking has to happen well within that 10 minutes. It proved easily done. The gel's physical role in the prosthetic is to keep the flocking in the gel rather than locked to the barrier, which does not work. Trust me, first test we did. Evan had found his color by mixing only 4 colors of flocking from photographs and this makeup sample from the day Joel was in the studio to have his head cast. Our flocking applicator was a large rubber bladder which took the flocking in through suction. A light squeeze blew out a fine, even mist of flocking. You can see how much control over how much flock we added. It was easy to see against the white. In this case, we applied as much flock to the gel as it would hold, like the bust. Once cured, loose flocking is blown away with air. Each appliance now will match perfectly, one to the other. Once cleaned, Anne can go back and fill any small missed areas using the same process. Don't go near silicone with anything made of latex rubber. Nothing. Our molds were made with injection ports to fit 60 cc irrigation syringes. Dedner gave us our gel by percentage, in this case 200%. Pigment toned the gel to the lightest tone of his skin. Polyester parafilm, not unlike a fine wax, releases all the core molds. These are injection cores. You can see the vent holes around the edge and the injection port in the center. We can be as generous as we like. A shiny surface does not matter on the core, like it does on the negative side of the mold. Pipe cleaners and metal rods keep the vent holes clean and checks them before closing the molds. Light, too, is important. I had 6-foot square skylights all through the studio. Most days we never turned the lights on. It was the only light that gave us true color. The molds have been designed with a single central clamp for even pressure against the urethane gasket. No injected material will pass that seal. Ice in a bucket keeps your silicone cold in order to maximize working time. Otherwise, we kept it in the freezer until we needed it. We have weighed our mixing container on our digital scale and balanced it to 0. We have already added our 200% deadener to soften both sides of the base silicone, in this case, Plat-Sil Gel 10. It's a simple 50-50 mix ratio now. We used a 50-50 mix ratio with all our materials by design to eliminate doubt. It was a valuable tool. We have colored one side, knowing that cutting it in half will give us the final color and opacity we need the interior gel to have. Polytech has made a thinner version of deadener that does not need to be vacuumed. It is only when you need to suspend a particle in the gel that you need a viscosity that needs to be vacuumed. This is the only time we actually didn't add flocking to the gel. It is mixed and then vacuumed. Vacuum bell jars like this are hard to find, but are important to see what you're doing. The vacuum pump has a lever that turns the vacuum on and off. Each time the vacuum is on, it pulls less and less air until it's gone. You control that. Once the vacuum has retrieved our color, it is poured into our 60 cc injection syringes. In this case, we needed 2, enough to fill the mold plus. The first fill is always a guess, but after that, you know precisely the volume needed to fill each mold cavity. Anne injects with a steady pressure as Jay wipes away silicone backing up through the port. so he can eventually seal that port while Anne changes over to the second syringe. As the mold fills, they watch for gel to come out of the vent holes. When it does, they let it run. Let any air out. Then plug the hole with a clay ball. They do that with every vent until they know the mold is full, with no air in it. We put our mold in a warm oven for about 10 minutes, ready to demold. Anne cleans the mold of its clay stoppers and remaining gel before removing the mother mold from the flexible urethane negative liner. The object now is to keep the prosthetic protected inside that liner while we release the backside of the prosthetic from the core. As there is no barrier coat on the core side of the prosthetic, the barrier gel is sticky. The gel has also filled all the vent holes locking the prosthetic to the core. 99% alcohol releases the stick holding the gel to the core, and a good pair of scissors cuts the vents free. The liner's flexibility makes that all possible. There are a lot of vents to cut free. None of it is difficult. It's just process. We were essentially making a self-sticking appliance by not putting a barrier on the core side of the prosthetic. We also had no need for a barrier on the backside of any prosthetic. The gel offered no resistance to the skin. It harmlessly sticks to the skin. It can be powdered to remove that stick and then glued or applied with silicone like we will do for this test. The remaining gel in the vent holes pushes out with a metal rod. A pipe cleaner with some alcohol cleans the vent hole, then a pipe cleaner with Vaseline releases it. We maintained the stick of the gel to keep the prosthetic clean and give us the opportunity to see and feel the prosthetic on our skin, our face, right out of the mold. Also, if there was a trap bubble in the gel, it was now easy to fill. We abandoned the self-sticking approach for a silicone bond because we had a lot of edges and hair punching to do. Bonding it with silicone was the same as adding a barrier coat on the core side of the mold, but this time on the actor. The Short-10 softness worked the best. It peeled off as part of the prosthetic. If self-sticking is not required, then powder it. The stick will never come back. Once the prosthetics were out, we could see we had made a mistake. The flocking had covered the edges that would eventually butt together, making a visible line we could not remove without physically trimming it off with scissors. It was disappointing because those edges were a big part of the theory we were applying to successfully match up one prosthetic to the next. Now, there was a new edge. So it was going to be all about the seaming material we had only tested. Once trimmed, we started putting the prosthetic together so hair could begin. You can see how well our seaming worked on these 3 appliances. The topical silicone paste, matted out to match the prosthetic with baking soda. We were still in the game. Now, finally, the brush cut could start. The tools of the trade. You file off the end of the needle, turning the hole into a fork to grab the hair, and sharp enough to cut cleanly into the silicone. Can't go wrong with a good pair of tweezers either. Anne has begun to punch his eyebrows. They'll be sealed with a barrier coat on the back side of the prosthetic. We have always done that. But I've often wondered how necessary it was, given the stickiness of the gel already held the hair firmly enough to manipulate the prosthetic, cut and style the hair without it, especially if we were applying the prosthetic with silicone, doing virtually the same thing. Beard stubble had no need to be sealed. It wasn't going anywhere, and it always looked great. Kelly McCallum punches the brush cut, applying the directional map we made of Joel's hair when he was in the studio. You can see here how the angle of that needle is very important to Kelly. It was a lot of work because we needed far more hair than we'd ever assumed, 4 or 5 times more than a normal wig, meaning it took a lot longer than planned. 2 more inches, and it would have taken no longer than building a normal wig. Once punched, the prosthetic was turned over and the excess hair was cut away. It was then ready for its first haircut. Jay seams the 2 halves of the head together so hair can finish. He will eventually mat out the shine of the topical silicone with baking soda, which, because of the size of the particle, simulates the matte qualities of both the silicone prosthetic and the actor's skin. What a prosthetic looked like in our hands was different to what it looked like on the actor because of the influence the actor's own skin tone had on the prosthetic. It was generally a matter of opacity to cancel out the grayness a prosthetic can take on. If too translucent, too opaque, it looks dead. A lot of things to consider, but every one controllable. If the test was just about seeing the brush cut, we were good to go. But if it was the prosthetic, that boat had sailed weeks ago. Our only remaining interests were application and if the camera saw it any different than the eye did. Once trimmed again, the underside of the prosthetic is given a thin coat of gel tin to seal the hair into the prosthetic. Again, for safety. Necessary? I don't think so. It is then flipped back over to cure. Once assembled back on Joel's bust, we finally get to see what we're dealing with. It was one appliance. It felt good. 80% of the seam work was done, which was good because it took a long time to do. And trying as hard as we could, we never did get the forehead seam to disappear. Hiding a seam is not a problem for a makeup artist, but we needed to preserve the surface detail and its pore structure. So we only topically colored with Illustrator Color and 99% alcohol. We made a silicone map so we could mark out on Joel where the prosthetic fit his face. Joel's hair was much longer now, and he would not let us cut it. So before starting, we knew he was going to have a fat head. The interesting thing, the prosthetic took on that new shape. It was still our first time putting it on Joel, and there was a lot of things we needed to know only the camera could tell us. After test fitting the appliance, and then waxing out his eyebrows, Jay and Ann apply Platsil Gel 10 to the crown of his head, down to his ears and eyebrows, following the map line. This will cure as part of the prosthetic in approximately 10 minutes. So you apply only what you can, well inside that 10 minutes. It proved easily done. Crazy as it seems, the prosthetic was one appliance. How well the idea worked, you can begin to see here. They have wrapped the rest of the prosthetic up out of the way while they work. Once Ann matched the forehead to its map location on Joel, the rest of the head should fall into place. The object here is to not trap air under the prosthetic. We built a form to duplicate the angle of his head cast so the prosthetic fell where it was sculpted. Once the skull was cured, they laid out the rest of the prosthetic to see how it fit and how best to put it down. We had to learn step by step as we went. This is where a test day would have been handy. All the hair work was beautiful, maintenance-free. We started with the nose and upper cheek. The volume of silicone they applied, I believe, was not necessary, but it was safe. Once down, they have time to move the prosthetic into place. Lift it, put it back down, fit it before the silicone cured. It takes time, but it's time you want. Now on Joel, for the first time, we could see everything that worked and everything that didn't. Everything we could improve in the next appliance. Hopefully one with a partial punch and a wig. Color-wise, it was obvious we needed to explore less flocking for more translucency, but that was easily done. Jay teaches us a lesson on less is more. We used the seaming paste to hide the few remaining butted edges. It worked as well as before, but it had a sudden surprise for us, something we had not been able to see until we began to see the prosthetic move on Joel. The problem was that the paste was a 60 shore firmness, not unlike 6 layers of barrier coat. It was nothing we felt in the prosthetic while handling it, and nothing anyone noticed other than us, but it retarded the movement along every seam line in the prosthetic like the prosthetic was glued down. We had firmed the gel up to 200% deadener rather than our normal, say, 250%. That too may have had an influence, but one way or the other, it wasn't moving the way it should have. But at least we knew that, so we could fix it. Most of every problem we saw, we could have at least tried to fix. We still wanted to see what camera saw. It was critical information only the camera could tell us. We never got to see that footage. But we did put the appliance on with no glue. We got to the set, and there were 2 comments. One from the cinematographer. I didn't think there was going to be so much makeup on it. The second comment was from the director. Wait for it. I didn't want him in a brush cut. I wanted him bald, with a fringe of long hair around his ears. It was a bit Monty Python to me. Nothing you could say would help the situation. It was still worth the effort, both in part and in whole. We had a whole new world to explore. Stay safe. The X-Men series explores the parameters of our platinum silicone gel prosthetic technology, documenting the makeups of Mystique, Nightcrawler, Sabretooth, Toad, and Senator Kelly. I add to that the encapsulated photographic tattoo prosthetics we pioneered to create this illusion. I would be remiss if I didn't take this opportunity to promote my book, Unmasked, in 2 volumes. It's available on Amazon Kindle. Thanks.